Hi, this is Mr. Doro. This is our fifth nomenclature video. This one's organic nomenclature, and it's going to just briefly touch on some naming and writing organic compounds. So what is an organic compound? Well, in short, it is a carbon-based compound. It has to have carbons in it. It can have other elements in it also, like hydrogens or oxygens. And these are all examples of some organic compounds. These are hydrocarbons, and all three of these are the same thing, C2H6. This is another way of writing it, and this is the structural formula. And there's a little bit different on each one of these. You can see on this C6H12 that it's actually a ring structure, and on each corner there'll be a carbon, just like we have on this structural formula here. Well, the most important thing that you need to know about organic compounds and naming them is the base of the names. And so this, if there's only one carbon, the longest chain of carbons, we'll see what that means in a minute, then it's meth, 2 is eth, 3 is prop, 4 is bute, and 5 is pent, 6 hex, 7 hept, 8 oct, and 9 non, and 10 dec. You're going to want to write those down because that's something that you'll need to memorize. Now the end of that base name is going to depend on the type of bonds that happen between the carbons. And if they're all single bonds, then it's going to be something called an alkane, and the ending is going to be an ane. So here's an example of an alkane. These are 2 carbons. It's the skeleton formula for them because there's no hydrogens on them. 2 carbons, and so since it's 2 carbons, that would be eth would be the prefix, and ane would be the end, so that would be ethane. This next one has a double bond in it. That would be an alkene. Alkenes end in ene. And so the name of this one would be, since there are 3 carbons, that'd be prop would be the base, and then ene would be the for the double bond. And then alkynes have triple bonds, and they end in yne. This has got 4 carbons. That would be bute, and would be ine or butine. In order to name these carbon-containing compounds, we have to find out what the longest continuous chain of carbons are in the compound that we're talking about. I've got several skeleton formulas and one that's not a skeleton. It has the actual structural formula. But this first one is a skeleton formula, and so I'm going to count the number of carbons in the continuous chain. And that can go around a corner too. So if I start here at the end and I go up, that's 4 carbons in a row. But if I go straight across, that's 5 carbons, and that's going to be my longest chain. Sometimes I just put a line right through that, and I know that the prefix for 5 is pent. I can see that they're all single bonds in between there, so that's an alkane, or that would be pentane. But I have to name this substituent group. That's what this is called, the little branches that are on there. And in order to do that, I have to locate where that substituent group is. I have to start at one of the ends, and I have to number the carbons. And whichever end I start at, this is 1, 2, 3, 4, 5. I have to start numbering from the end that is closest to the substituent group. In this case, it doesn't matter because it's on carbon 3 no matter which way I go. So that's going to help us out. I'm going to identify, I'm going to say that that substituent group is on carbon 3, and I'm going to put a name in there a little bit later on. Let's go over this next one though. The longest continuous chain that we have, if we go across here, this is 1, 2, 3, 4, 5, 6 going this way. But if I go down the corner here, this is going to be 7. That's going to be my longest continuous chain. So I have 7 carbons. They're all single bonds. So 7 is hept. Since they're all single bonds, it's heptane, and I have this one substituent group, so I have to say the location of that. And if I start numbering from this side, it's 1, 2, 3, 4, 5 on carbon number 6. If I start going from this way, it's on carbon number 1, 2, 3. So I have to start from this end, the end that's closest to the substituent group. So it's going to be 3 something, and I'll name that substituent group later on. We got the same thing down here. Actually, this is the same as the one right above it. There are 5 carbons. This just happens to have the hydrogens in it. And so this is on carbon number 3. There is this substituent group, so it's going to be the same as the one above it. Let's look at the next one though. Our longest chain of carbon is 1, 2, 3, 4, 5, 6. And so that is going to be hex is for 6, but it has a double bond in there. The double bond, so this is going to be hexene. And I have to say which carbon that's closest to the first carbon that's starting on. I have to number from this side, carbon number 2. So this would be called 2-hexene. So here's how we name those substituent groups. They have the same base, but they end in YL. For example, if there's only 1 carbon in the chain right there, methyl. If there's 2, ethyl. If there's 3, propyl. So if we go back to the last page, we can name these substituent groups. Since this first one only had one carbon up there, that is going to be 3-methyl, because meth is for one. And same with this next one right here, one carbon, that is 3-methyl also. If there were two carbons on that chain, like another carbon right up here, then that would be ethyl that we have on there. There's also an organic group called alcohols, and they're going to have an OH group in them. So if you see that they have an OH group on them, then it's going to be an alcohol. There's a little different way of naming those. It just ends in OL. So for example, this first one right here, it has one carbon, and the rest are hydrogens, and then it has the OH. So the one carbon is meth, but it is methanol is what this is. This one has two carbons and an OH and single bonds in there, so this is ethanol. This one is 3 carbons with the OH, so this is actually called isopropanol, and you may have heard of isopropyl alcohol, that's what this is, or isopropanol. And this one is actually 1-propanol because it's saying which carbon that OH is on, so 1-propanol or propanol. There also are ring structures, and ring structures, the only thing I want you to know is that for naming those, and the ring structure, the reason it's a ring is because you can see they're all connected with each other. 5 carbons, they're connected in a ring, and so you would put a cyclo in front of it to show that it's a ring structure. This one has 5 carbons, all single bonds, so this would be cyclopentane. And so I just want you to know that the cyclo comes on the front. Some examples on how to draw these. 3-methylhexane. I always start with the base unit, and so the base is hexane right here. And so hexane means it has 6 carbons, all single bond. I'm just going to draw the skeleton equation. There's 6 carbons, and then on carbon number 3, there's a methyl group. That means 1 carbon on carbon number 3. I could have drawn it on top or bottom. I actually could have drawn it on this carbon also if I started numbering from the other side. 2-octene. Octene means that there are 8 carbons, 2, 3, 4, 5, 6, 7, 8. 8 carbons, and there is a double bond because of the ene inside of that, and it's on carbon number 2. It actually comes after carbon number 2, so I would have a double bond right there. Cyclobutane. Butane means 4 carbons and all single bonds for the ane part. Cyclo means that they're in a ring, and so I would put those all in a ring like that. When you see this 2,2-dimethylheptane, let's start with the heptane part of it. Heptane is 7 carbons, and so I'm going to draw 7 carbons, all single bonds. And then it says 2,2. So on carbon number 2, there's a methyl, and on carbon number 2, there's another methyl group. So how do you do that? Well, pick what carbon number 2 is, and I'll pick this one, and then right there again, 2 methyl groups on that carbon number 2. And then finally 1 butanol. But means 4 carbons, and so I'm going to draw my 4 carbons. And the all means that there is an alcohol group, an OH group, and it's on the first one, and so I'm just going to draw it right up here. So now we get to name them the other way around. And so we find the longest carbon chain. And so the longest carbon chain in this first one is going to be 4 carbons. I could have went several ways to find 4 carbons. But so the 4 carbons, all single bonds, is going to be butane. And I have 2 substituent groups. I start numbering my carbons from one of the ends on my chain. And so that the one that's closest to the substituent group, in this case it doesn't really matter. Either way, it's going to have a methyl on 2 and 3, and so that would mean since there are 2 methyl groups, I put dimethyl, and I have to say where they are at, and I put a dash, and I put 2-3 or comma 3. So on carbon number 2 and carbon number 3, there's a methyl on that butane. For this next one right here, my longest carbon chain is the 5 carbons, and they're all single bonds, so that is pentane. And there is an alcohol substituent group. On carbon number, I have to start numbering from this side, 1, 2. So this is 2, and instead of pentane, this is going to be pentanol. 2-pentanol. This next one, I have 4 carbons in a row, so that is bute. And then there is a double bond, so that makes it butene. And I have to say where that double bond is. I can't start numbering from this side, because it would be on carbon number 3, so I have to start numbering instead from this side, that makes it on carbon number 1. So this is 1-butene. And then finally, this last one, we have 1, 2, 3, 4, 5, 6, 7, 8 carbons, and so that's oct. And there is a triple bond, so octine, and I number my carbons from the end that's closest to that, 1, 2, 3. So this would be 3-octine. Well, that was a lot of information to throw at you in a very short amount of time, and really we only scratched the surface. I just want you to know how to name and write formulas for some basic organic compounds. So here's some for you to do. There are 7 of them here, 4 of them that you have to write the formula, and a skeleton formula is just fine, or if you want to fill in the hydrogens, you can do that, and 3 of them where you have to name them. When you get down to this bottom one down here, letter G, that HO is just a different way of writing OH, so that's going to be an alcohol group that's on there. Okay, have a good day.